When we search for life beyond Earth, our minds often go straight to Mars. But hundreds of millions of miles away, another world may be hiding something far more mysterious. It is called Europa, one of Jupiter's largest moons. From a distance, Europa looks like a frozen, lifeless world, covered almost entirely by a thick shell of ice. Its surface is crossed by enormous cracks and reddish-brown markings, giving it an appearance unlike almost anything we see on Earth. But beneath that frozen exterior, scientists believe something extraordinary may exist, a vast ocean of liquid water. And if that ocean really exists, Europa could become one of the most important places in the entire solar system in the search for extraterrestrial life.
Europa is smaller than Earth's moon, but what makes it fascinating is what may be hidden beneath its surface. The temperature on Europa is extremely cold, so cold that liquid water cannot normally remain exposed on the surface. Yet scientists have strong reasons to believe that beneath the ice, conditions could be completely different. Europa may have a global ocean containing more water than all of Earth's oceans combined. But how could liquid water survive so far from the warmth of the sun? The answer may be Jupiter itself.
Jupiter is enormous. Its gravitational influence is powerful enough to constantly stretch and squeeze Europa as the moon travels around the planet. Europa also interacts gravitationally with other moons in the Jupiter system. This creates a phenomenon known as tidal heating. In simple terms, Europa is being flexed by gravity. That constant movement can generate heat inside the moon, and that heat could help keep an enormous layer of water beneath the frozen surface from completely freezing solid. This possibility changes everything. Because on Earth, water is one of the fundamental ingredients associated with life. But scientists know that water alone is not enough. Life also needs energy and the right chemical ingredients, and that is where Europa becomes even more interesting. On our own planet, life exists in places that once seemed impossible. Deep beneath the ocean, around hydrothermal vents, entire ecosystems survive without sunlight reaching them. Instead of relying directly on sunlight, organisms in these environments can depend on chemical energy. This has given scientists an important clue. If Europa has a liquid ocean, and if chemical energy is available on its ocean floor, then perhaps life could exist there without ever seeing the sun. But there is an important distinction. Scientists have not discovered life on Europa. There is currently no confirmed evidence of extraterrestrial organisms living beneath its ice. What scientists are investigating is whether Europa has the environmental conditions that could potentially support life. And that question is difficult to answer because we cannot simply look through the ice. Europa's outer shell may be many miles thick. Drilling through it would be an enormous engineering challenge. Instead, scientists are looking for clues from above. Spacecraft have studied Europa during flybys, while powerful telescopes have observed the moon from Earth and from space. Some observations have suggested that water vapor may occasionally escape from Europa's surface in enormous plumes. If those plumes are real and can be studied directly, they could provide scientists with something incredibly valuable, a natural sample from Europa's hidden environment. Imagine a spacecraft flying past Europa. Below it is an enormous frozen landscape. There are cracks stretching across the surface, strange ridges, and regions that appear to have been reshaped over time. Somewhere beneath that ice could be a global ocean. And then, potentially, a plume rises from the surface and sends microscopic particles of water and other material into space. A spacecraft would not need to land, drill through miles of ice, and reach the ocean. It could potentially fly through the material and analyze it. That is one of the reasons Europa has attracted so much attention from planetary scientists. But reaching Europa is not easy. Jupiter is surrounded by an extremely intense radiation environment. Its powerful magnetic field traps high-energy particles, creating radiation belts that can damage spacecraft electronics and instruments. Any spacecraft designed to study Europa has to survive this hostile environment while collecting extremely precise scientific measurements.
NASA's Europa Clipper mission was designed specifically to investigate this mysterious moon. Rather than simply landing on Europa, the spacecraft is designed to make repeated close flybys, using a collection of scientific instruments to study the moon's surface, composition, ice shell, and internal structure. The mission is not simply asking, is there life on Europa? The scientific questions are more fundamental. How thick is the ice? How deep is the ocean? What is the chemistry of the surface? Is water moving through the ice? Are there signs of geological activity?
And most importantly, does Europa possess the chemical energy and environmental conditions that could make its hidden ocean potentially habitable? That last word, habitable, is extremely important. In science, habitable does not mean inhabited. A place can have conditions suitable for life without actually containing life. Scientists have to separate those two ideas very carefully. Finding water would be exciting, but it would not prove life exists. Finding organic molecules would also be exciting, but organic molecules can be produced by non-biological processes. Even finding complex chemistry would not automatically mean that Europa has living organisms. Scientists would need multiple lines of evidence before making such an extraordinary claim. And that is what makes the search so fascinating. Europa could force humanity to rethink one of the biggest questions we have ever asked. Is life a rare accident that happened only once here on Earth? Or can life emerge wherever the right ingredients and conditions exist? For most of human history, we had no way to investigate that question scientifically. We could only look at the stars and wonder. Now, we can send machines into space. We can study distant planets. We can analyze the chemistry of worlds hundreds of millions of miles away. And we can search for environments where life might exist. Europa may be one of the best natural laboratories available to us. But there is another mystery. If Europa really has a huge ocean beneath its ice, how did that ocean form? How long has it existed? Is the ice shell completely solid, or does it contain cracks and pathways through which chemicals can move? Is the ocean connected to a rocky seafloor? And could interactions between water and rock provide the chemical energy necessary for life? These questions may sound like science fiction, but they are real scientific problems being investigated today. And Europa is not the only place scientists are interested in.
Another moon of Saturn, Enceladus, also appears to have a subsurface ocean and has been observed releasing water-rich plumes into space. This means that our solar system may contain multiple icy worlds with hidden oceans. Suddenly, the search for life is no longer limited to planets that look like Earth. That could be one of the biggest changes in modern planetary science. We once imagined that a world needed to resemble Earth: blue skies, oceans on the surface, sunlight, and a warm atmosphere to support life. But icy moons challenge that assumption. Perhaps life can exist beneath kilometers of ice. Perhaps an underground ocean can remain stable for billions of years. Perhaps sunlight is not essential. And perhaps the most important environments for life in our solar system are not the worlds we can easily see, but the oceans hidden beneath them. Now imagine what it would mean if a future mission eventually found convincing evidence of biological activity in Europa's ocean. It would not just be a discovery about Jupiter's moon. It would change our understanding of life itself. For the first time, humanity would have evidence that biology exists somewhere beyond Earth. We would know that life is not unique to our planet. And suddenly, the number of potentially habitable environments throughout the universe would become even more important. But there is another possibility.
Europa could be completely lifeless. Its ocean could exist, yet the chemistry might not be suitable for biology. The energy available might be insufficient, or perhaps life simply never emerged there. And even that answer would be incredibly important, because knowing where life cannot exist is just as valuable as knowing where it might exist.
Every measurement from Europa helps scientists narrow down the conditions necessary for life. So when we look at Europa, we are not simply looking at a frozen moon orbiting Jupiter. We are looking at a world that may contain an ocean hidden beneath its surface. An ocean that may have existed for millions or even billions of years. An ocean that never sees sunlight. An ocean that may interact with a rocky seafloor far below the ice. And somewhere in that darkness, there may or may not be something extraordinary. Right now, we do not know.
And perhaps that is the most exciting part of the story, because humanity is finally sending machines capable of getting closer to the answer. Europa reminds us that the solar system is far stranger than we once imagined. The worlds around us are not simply dead rocks orbiting a distant sun. Some may have oceans beneath their surfaces. Some may have complex chemistry. Some may contain environments unlike anything on Earth. And somewhere beyond our planet, perhaps beneath an enormous shell of ice, the universe may be waiting to answer one of humanity's oldest questions. Are we alone?